Yeah, welcome to JAMB Chemistry Class 4. JAMB Chemistry Class 4. That's Class 4 where we are. And the question they ask in this Class 4 says, which of the following orbitals of carbon are mixed with hydrogen in methane? He said, which of the following orbitals of carbon are mixed with hydrogen in, can you come over here, in the methane? They said A, 1x and the 2p, B, 1p and the 2x, C, 2x and 2p, D, 2x and 3p. I don't know. But before we go into that, we now have to know about what we call what? SP and the orbital. We say solution. Hybridization. Hybridization is the process of mixing pure orbitals to form new equivalent orbitals. Do you understand what I said? Hybridization is the process of mixing pure orbitals to form new equivalent orbitals. Now, let us take the look at the electronic configuration of carbon. Let us look at what electronic configuration of carbon. Carbon has 6 electrons, and you look at it, 6 electrons will give me 1s2. 2x2 and 2p2. That's the carbon. The electronic configuration of carbon is what we are using as our reference point, because when we talk about what hybridization, xp and the xp2, xp3, xp hybridization, we are talking about what? Carbon. We say electronic configuration of carbon is 1x2, 2x2, 2p2. Then look at its filling. That means the x orbital is filled up. Spill in and spill out is filled up. This x orbital is also filled up. Spill in and spill out. This would be spinning the electron entering and electron out. That filled it up, that double electron. Here in p orbital, we have 2 electrons which only spin in, and we have empty box here. P orbital has what? A maximum of electron of 6, you remember. Therefore, each box supposed to have 2 electrons here, 2 electrons here, 2 electrons in this box, making it 6. But what happened? He has only 2 electrons here, which give me 1 in, 1 in. Because we will first of all go in before going out. Are you get what I'm saying that? We will first what? Go in 3 boxes before what? Going out in each of the boxes. Therefore, going in, we have only 2, while this one remain on what? On paired. What I said, if the energy is applied to this ground state, because this is a ground state configuration of what? Carbon. This is a ground state of what? Carbon. Carbon has what? Electron of what? 6. And its ground state of electronic configuration is this. What do you mean by ground state? Ground state means when atom is at relaxed state, there's no energy supplied to him. Then now, let us excite him. What do you mean by exciting him? Give him what? Energy. Heat, which was energy to carbon. We said if energy is applied to this ground state configuration of carbon, if energy is applied to this ground state configuration of carbon, are you listening? Are you seeing this place? One electron will be transferred from what? 2x orbital to the empty p orbital. Will be transferred to what? From 2x orbital to the what? Empty p orbital. When will this happen? When we what? Excite him. When we supply what? Heat on him. That's why we said if energy is what? Apply. What is the energy? Heat. That we call excitation. We excite the what? The carbon from this what? Ground state. Then what will happen? We said this one of the electron here will now what? Be excited and what? Enter to fill this what? P orbital. And inside this p orbital we have x, y, z. This x, y, z. What does it mean? Px, py, and pz. Then looking at it, and I call it what? Pz. Look at it. This is pz. Then when I said, we then have the excited what state configuration of carbon atom. Now look at the excited state of configuration of a carbon atom. This man had been excited. He had to run and complete this what? Open what? Box. And look at it. He comes here to enter. That's what we call excitation what? State of what? Carbon atom. Look at the grand state of what? Carbon atom configuration. Look at the excitation state of what? Carbon atom. And you remember that here is what? Px, and here is what? Py, and here is what? Pz. He have run in and gone into what? Pz. Sp3 hybridization. Grand states of carbon, which we have explained. Carbon has six electrons. And that 6 electron, look at the configuration in a what? Grand state, when energy have not given to atom. When the energy have not given to carbon atom, look at the grand state configuration. Now, when the energy is supplied to atom, why do we supply energy? To excite the carbon atom. By the time we excited the carbon atom, we call it what? Excited what state? Excited what state of what? Carbon. See, this is present carbon. He's giving us what? This man, one of these will leave and go what? And fill the 2p orbital in order to form 3 to fill it. Then now, remember, we want to produce 3 xp3. We say in order to produce 4 identical bonds. In order to produce 4 identical bonds, because carbon needed 4 identical bonds. What is that carbon? You look at the carbon now, watch here. Carbon need what? 4 identical bonds. Look at the 4 identical bonds of carbon. For carbon to produce these 4 identical bonds, this man have to mix up with this to form what we call xp3. xp3, look at this man now is 1 here. Mixing up with what? 2p3. We now form what? xp3 what? Hybridization. In order to produce what? Because carbon is what exists where all these xp3, xp2, xp hybridization occur is in only what? Hydrocarbon. And in hydrocarbon, carbon needed 4 bonds to react with what? Hydrogen. You remember, in hydrocarbon, carbon needed 4 bonds. And for carbon to produce these 4 bonds, which is used in a what? In a reaction, this man have to mix with this. That means this and this will form the 4 electron, which is what? 4 bonds. And that's what we are saying here. I said, in order to produce 4 identical bonds, carbon must contribute a set of 4 equivalent what? Orbitals. A set of 4 equivalent orbitals. This is done when the 2x orbital, which is this, and the 3p orbital, which is this. In the excited state, you see that this xp3 orbital is produced in a what? Excited state of what? Carbon atom, not in a grand state. In what? Excited state of the what? Carbon are mixed together or hybridized. When you hybridize mean what? Mixing together. Are mixed together or what? Hybridized to form 4 new equivalent orbital. Are you gonna say that? Therefore, we now say these new orbital are known as what? Are known as what? xp3 hybridized orbital. xp3 what? Hybrid what? Orbital. That's what I'm explaining here. We said for me to form xp3 hybridization, I have in a excited what state of what? Carbon. This man have to mix to this man to form 4 identical what bond. You know that carbon needed 4 identical bond, as I explained. This man now and this will mix up to form that 1, 2, 3, 4 identical bond. And that 4 identical bond is what we are now producing what? xp what? 3 what? Hybridization. And these 4 identical bonds are present in what? Methane. Look at it. This hydrogen, look at hydrogen, look at hydrogen, look at hydrogen. So we now say that this man is what? Methane. And the methane is a what? Alkane series. Alkane what? Series. Therefore, we now say the sp3 hybridides are found in a what? Alkane. And one of the members of alkane, which is the firstborn of alkane, is what? Methane. So we now see that these man are formed here because this carbon have to hybridize this to form what? Four what? Bond, the identical bond for this hydrogen to be what? Attached. Therefore, doing that, we form what? sp3 what? Hybridization. This is where we find it in a what? Alkane or what? Methane or ethene. These sp3 hybridization are found there. Then I'm not coming and tell you, note, this means note that what? sp3 orbital are formed when one s orbital, which is this, mix with what? Up with what? 3p orbital, which is this. It's just like when you mix 1 liters of what? Pure red paint with 3 liters of white paint, and you form 4 liters. What do you form? You form what? 4 liters of what? 4 liters of what? Of what? Pink what? Paint. What does it mean? I have 1 liters of what? Red paint plus what? 3 liters of white paint. I will produce what? 4 liters of what? Pink paint. This pink, that's what we did here. When I bring 1 electron here of this man mixed up with what? 3 of this man, I will form what? sp3 what? Orbital. And that's what I'm explaining. It's just like I said, it is just like when you mix 1 liters of pure red paint with the 3 liters of white paint, and you form 4 liters of what? Of pink paint, which I explained here. Red paint plus what? White paint, which is 1 liters of red paint plus 4 liters of white paint will give me 4 plus 3 liters of white paint will give me 4 liters of what? Pink paint. And I said that is, this means what? That is 1x1, which is this, look at it, 1x1, then and what? P3. I can say that 2p what? 3. That means 2x1, I need to say 2x what? 1 and what? 2p3. What is 2p what? 3. What does it mean? 2x1 mixing up with what? 2p3. We produce what? sp3 what? Hybridization. And that's, I cannot claim this. I know that this is x orbital, this is x orbital. But in the specification, I can say what? 2 and what? This one. 2. You look at this man mixing with what? This. So that it will be specified. This man now mixing with this to produce what? This. Then I said the electronic configuration of sp3 after they have what? Mixed up. The electronic configuration, new electronic configuration in that excited what? State. After they have mixed up to form what? sp3 what? Hybridization. And I said the carbon will now become what? Look at their new one. This 1x2. Look at it here. Excited state. This man have mixed up with this man. This man now is this one. Come over here. Look at it. And this man now here, come over here, have what? Mixed up with this man. And he is going to produce what? 2. Because they are 2 sp3 1. This is 1 electron. This one stands for 1 electron. This one stands for what? That sp that form with what? p3 is what? 2. Look at it. 2 xp 2p. Then 2 is common. I bring it out. It becomes 2 xp3. Look at. Watch what I'm talking about. This is supposed to be what? 2 xp3. I think you know. This man will give me 2 xp3. Then these 2 are common to both of them. I will not say what? 2 out, xp what? 3, and that's what? 1 electron. That's what you see here. Are you going to say that? 2 out, and I have what? xp what? 3 what? And that's what? 1. You remember that what form that is what? 2 xp1 and plus what? 2 what? p3. And that gives me what? 2 xp3. And that can be written as 2 into what? xp what? 3. Are you going to say, you know, raised to power 1. What's the 1 here? 1 here represents the what? Electron. Come down here. 1 represents this what? Electron. This man have mixed up 1. Then the second one, 2 xp3, 1 as well. Then the other one, 2 xp3, 1 as well. How many are there? 1, 2, 3, 4. And this is the 4 identical what bond that carbon will use to react to other what elements. And that's what is produced in excited what state. That's what we produce in excited state. And that's the electronic configuration of what sp3 hybridized. Now, after we have gone through the whole explanation, we now find out that what our option for the answer of this is what? Option C. Option C is our answer here. My answer is option what? C. What happened to option C is a mixture of what? 2x and a what? 2p that is existing in a what? Methane. And how do they exist? We call it what? We call it what? xp what? 3. The percentage x orbital and p orbital in sp3 hybrid is what we want to look at now. We want to look at the percentage of what? X orbital. You know that we'll say that x orbital mixed with p orbital, 2x orbital mixed with 2p orbital to form what we call sp3 hybridized. So we want to know the percentage of what? X and what? P orbital, x orbital and p orbital in the sp3 hybridized. And I said percentage of x. Looking at it, we know that we are talking about what? xp3. Therefore, the number of x here is x raised to power 1. That's the x1 over what? xp3 times 100 over 1. Are you get what I'm saying now? Then now, this x1 is 1 electron, that is means, and what? X here is 1 as well. And p is 3p. Look at it, 3 electron. Why this one is 1 electron, which is 1 plus 3, which is 3 electron. And this 1 over 1 plus 3 times 100 over 1. Look at it. Then this give me, this plus this will give me what? 4. And that's 1 over 4 times 100 over 1. And this means that 100 divided by 4 will give me 25%. That's 25% of x orbital is mixed in what? P orbital. When I look at percentage of p orbital, percentage of p orbital become what? P raised to power 3, which is what? P electron 3 all over what? xp3 times 100 over 1. Are you get what I'm saying now? Because we are looking at percentage. Percentage means what? That value over the total. What's the total? xp3. And what's the value we are talking about now? xp3. And the value we are talking about now, xp, that is the p3 over what? xp3, which is total. xp3 is total. Then what we are looking for is what? p3. Then times 100 over 1. Then p3 is 3 in number, electron is 3. Then x is 1, and p3 is also what? 3 here. And it becomes 3 over 1 plus 3, giving me what? 4, which give me what? 3 over 4. 3 over 4 times 100 over 1. You see it? 3 over 1 plus 3 give me 4. 3 over 4 times 100 over 1. And that's what we see here. Then now, 3 times 100 will give me 300. Divided by 4 will give me 75%. And when we check it, 75% plus 25% will give me 100%, which is what? The total of x and p in what? xp3 hybridized. And that's the percentage. Note it now. Then we come to this. The shape of an sp3 hybrid is tetrahedra. Tetrahedra is this shape. Look at the shape of tetrahedra. Then we say the sp3 hybrid is found in what? Alkane. I have mentioned it. That sp3 hybrid is found in what? Alkanes. Then example is what? Methane, which we see the first born of what? Alkane. This methane is first born of what? Alkane series. You know that alkane is homologous series. Is a what? A lineage. Are you get what I'm saying now? Is a lineage. That's what we call homologous series. Therefore, this man is found in this homologous series. Reason? Because sp3 hybridized make use of 4 electron and 4 bond, 4 identical bond. Therefore, it has no what? Extra bond. Then here, look at the angle. Look at it. 1, 2, 3, 4. Have you seen it? The hydrogen. That's the 4 identical what? Bond, which produced by what? Combining x orbital, 2x orbital, and what? 2p orbital to form this bond. This 1, 2, 3, 4 bond. That's where the carbon has that characteristics of what? Bond to itself. Then now we have 109 degree, and this is what? 28 minutes. 28 what? Minutes. Then the angle is what? 109 degree, 28 what? Minutes. That's the angle between the two what? In between the bond. Then we will now say the bond angle is what? This. Then bond length of this, the length of the bond is 1.09. And what does it mean? This means what? There's 10 raised to power what? Minus 10. This is 10 raised to power minus 10. This value stands for 10 raised to power minus 10. Therefore, we'll put it here. Then now, coming to this, Alan said this is what we call sigma bond. It's only sigma bond that exists in what? Alkane series. Alkane series has only sigma bond. What do we call sigma bond? A single bond, which we are going to see when I go into explaining the sigma bond. You will see that sigma bond occur only in a single bond. Look at single bond, single bond, single bond, single bond. That means that is a sigma bond that exists in a single bond. That sigma bond exists in what? Alkanes. Note it now. Sigma bond is found in what? Alkane. And what? sp3 is found in what? Alkane. Only sigma bond that is found in what? Alkane. Note, this means what? Note, the tetrahedral shapes is obtained. Tetrahedral shapes of this sp3 orbital is obtained because the electrons move as far as possible. Are you there? As far as possible away from each other, because they are like terms. sp2 hybridization. sp2 hybridization. You remember that carbon has already been excited, and the sp2 of carbon has 3 electrons. Why 2x has 1 electron. You remember that in an excited state of what? Atom, which is carbon, the one that is in the 2xp give 1 electron to complete the other one. We said in sp2 hybridization, 1 electron of 2x orbital mixed up with 2 from 2p orbital. You remember that this 2p orbital has 3 electrons. But these 3 electrons he has because of in an excited state of what? Carbon. In an excited state of carbon, this 2p orbital has 3 electrons, while this 2x orbital has 1 electron. Then 1 electron on this man is used to what? Mix up with what? 2 from what? 2p orbital. Instead of mixing up with the 3 that is in the what? 2p orbital, but they only mix up with what? 2, leaving one of the p orbital unhybridized. Leaving one unhybridized. It's only 2 that they use to mix with what? 2x orbital. Then they leaving one p orbital unhybridized, and this unhybridized orbital in p orbital, which is this, is used to form what? A pi bond. Why? It's used to form a pi bond because pi bond is as a result of what? Double bond. This double bond is found in a what? Alkene. Double bond is found in alkene. Therefore, this unhybridized what? Electron is used to form what? Pi bond. And this pi bond, since only one is unhybridized, the only one pi bond will be what? Formed in the what? Alkane. We said it's found in the what? Alkane. We said one pi bond is found in the what? Alkane. And what? In the what? Alkene, I mean to say, not alkane, in the what? Alkene. Only one pi bond is found in what? Alkene. Can we see this example? If I have alkene now, look at alkene. Look at alkene. Look at the 2 bond. This double bond now. Look at the double bond. This pi bond is used, the unhybridized what? Electron in the what? P orbital, which is that electron that's supposed to what? Complete what? Z. You remember that we have this orbital like this, which is this and this. And this man is what? P what? X, and this P what? Y, and this one is P Z. So it's only use this man and leave this man unhybridized. This 2 is used with what? This 1x what? 2x what? 1. This man and this man are used to mix up to form what? xp2 hybridized. Leaving this man unhybridized because they don't make use of this man. This man that they leave unhybridized is used to form what? Double bond here. And that double bond is what we call pi bond. Look at the pi bond here. Why this man is a sigma bond? Look at it. So this man contains what? Sigma bond. Single bond. If I remove this pi bond, I will have one single bond, which is what? Sigma bond. Sigma bond is what? Single bond. By this man forming double bond because of as a result of what? Unhybridized of what? PZ. Then form what's used to form what? Pi bond. Then when I say the configuration of xp2 is what? Look at it. This man have been used 1, 2, 3. Leaving this man what? Unhybridized. Look at the 2pz is what? Unhybridized. The only one they use here, this one is what? For what? X, 2x. This one now for 2p. You understand now? They now mixed up to form what? xp2. Leaving this man what? Unhybridized. And I said this leave 2pz unhybridized. Have you seen it? He leave this man unhybridized. We didn't make use of it. We only mix this and what? This xp orbital. Then when I say xp2, the shape of xp2 hybridized is a triangular what? Planar. Triangular planar. This man has a triangular planar. That's xp2 has a triangular planar. Notice now as you are going for your JAMB what? Exam, they has what? Triangular planar. That's xp2 hybrid is what? Triangular what? Planar or what? Triangular, which would have what? The shape of triangular planar. And the xp2 hybrid is found in what? Alkene. It's found in the what? Alkene, which I've said is found in alkene. Example is found in alkene. An example of alkene we have there is what? Ethene. The first bond of what? Alkene is what? Ethene. This man is what? Ethene. If I put hydrogen here, and hydrogen here, and hydrogen here, and hydrogen here, I form what? I form what? Ethene. And inside this ethene, we have what? Pi bond and what? Sigma bond. Can we see the angle which is formed by xp2 hybrid? This is the angle. We said it's a triangular planar, and the angle between the two bond is 120 degrees. The angle, the bond angle is what? 120 what? Degree. Then I come over here to say that what? Example of this man where is being found. xp2 orbital is found in the what? Alkene. And alkene has double bond. And that's the reason why we have, for me to remove this double bond, meaning that this second bond is what? Pi bond. And how many pi bond do I have here? 1. And how many sigma bond? You see, this is a sigma bond. Sigma bond is a single bond, and we are going to explain it later. I'm going to detail you what we mean by sigma bond. Sigma bond. Sigma bond is a single bond. Look at single bond, single bond, single bond, single bond, single bond. And this give me sigma bond. But this man appear to have double bond. The double bond appear to it is called what? Pi bond. If I remove this and have a single bond here, I'm going to form what? Alkane. And alkane, we say is only sigma bond that exists in what? Alkane. And this pi bond come as a result of what? Unhybridized what? Unhybridized what? 2p orbital z. Of 2p orbital unhybridized, which I have explained. That's what brings this what? This pi bond. So when I say that how many sigma bond is here? 5, and how many pi bond can get it? 6. You see now 1, 2, 3, 4, 5 of what? Sigma bond. Why pi bond is only 1. Then I come to what? The percentage of what? X and P in xp2 hybrid. We said the percentage of what? X and what? P in a what? xp2 hybrid. And I said percentage of x orbital. Percentage of x orbital. Give me x, which you call, what I'm talking about is x orbital. I have x over total. What is the total? xp2 is total. Then x, we are looking at x inside what? xp2, which is what? Total. Then now times 100 over 1. And the x is 1. When you go to x, it's only 1 electron that is there, which will show like that there. If you now have 2x, what you see there is 1 electron that was spinning. I know what I'm saying now. Then when I say that 1 electron is what to write here. Then in p orbital, we have now here, we have what? 1 electron also, and this man p orbital has what? 2, which is p2. Then we have 2 here, times what? 100 over 1, and this will give me 1 over 3, because 1 plus 2 will give me what? 3, and this is 1 times 100 over 1. And when you times this, it means that what? 100 divided by 3 will give me what? 33.333, approximately what? 33.3 what? Percentage. And I come to what? Here, come over here. We come over here, we say what? Percentage of P, which is what? P orbital. Then I have to bring out P over the total. And what is the P? P2, right? And over the what? Total, what is 2? XP2, that is the total. Times 100 over 1, and the P2 is 2 electrons, that is the P2, which to make use of two electrons there to mix up. And this man now is 1 electron, and this man is 2 electrons, which being 1 plus what? 2, and that will give me what? 3. That means 2 over 3. Look at the 2, look at it here. That's this plus this will give me what? 3 times 100 over 1, and that means what? 200 divided by 3. 200 divided by 3 will give me what? 66.7 approximately. 0.7 percentage. If I add this and this, it will give me 100%, which is what? Accurate. Then when I come to the last stage, which we call XP